Hello and welcome to this video where I will show you a step-by-step guide to creating another ESP32 project. In this tutorial, I will be introducing the concepts of the I2C bus and developing together with you a project to scan the devices on the I2C bus and acquire their addresses. Let's take a look at what we'll be covering. The aims of the project are to introduce I2C bus concepts, build an I2C bus scanner and detect the addresses of the I2C devices. If you find this video useful, please press the like button and subscribe to the channel. These things are free for you and they really do help the channel develop. I will also end the tutorial with a number of exercises. Now a quick word about my development environment. I have developed this tutorial using ESP32 DevKit v1 hardware. Please check your pinouts if you're using a different ESP32 variant. Note also that the solution presented in this video will only work with ESP-IDF version 5.1 or later. I2C is an acronym for Inter-Integrated Circuit. Is a simple short-distance communications protocol to allow chips to talk to each other on the same circuit board. It allows one or more controllers to talk to many devices using just two wires. The two wires are SDA, which carries the serial data, and SCL, which carries the serial clock signal. All devices share both lines and the lines require pull-up resistors. Often though, I2C devices have pull-up resistors built into their circuit boards. Devices are organized as either master or slave. The master initiates communications and provides the clock signal. Slave devices respond when addressed. Addresses used by I2C are usually 7 bits and very occasionally 10 bits in length. In this tutorial, we will scan for the presence of master and slave devices. The component block diagram shows how the I2C components are wired. The ESP32 is the I2C master and the OLED display and AHT10 temperature sensor are slave devices. The VCC pins on the OLED and AHT10 devices are wired to the 3v3 pin of the ESP32. The SDA pins are connected to the D21, that is the GPIO21 pin of the ESP32, and the SCL pins are connected to the D22 GPIO22 pin of the ESP32. Now then, let's get on with coding this project. Just a note about compatibility. Make sure you are using ESP-IDF version 5.1 or more recent. If you have been following my ESP-IDF installation videos, you will already have version 5.5.1 installed. See the link to the playlist in the description below. Let's start by using a previous project as the basis for this project. If you have been following my tutorial videos, you will have a project called button_LED. We will use this as the basis for our new project. If you don't have this project, then I suggest you watch a previous video. The link is in the description below. Copy the project and rename it I2C_scan. Now open VSCode and then open the I2C_scan folder. Now open the YAML manifest file at main idf_component.yaml. Delete the line with LED_strip. Keep the line with the button, otherwise the build will fail. Save the file using Ctrl+S. Now open the main.c file. Delete everything from the top as far as the app_main method. Inside the app_main method, delete everything as far as the while loop. Inside the while loop, make sure you have the vtask delay call with a value of 1000. Now we will start coding for scanning the I2C bus. Let's start by adding some general ESP-IDF header files. Now we need a specific ESP-IDF header file for I2C. This header file is only for ESP-IDF version 5.1 or later. Now let's customize our logging tag. Now add the defines for the I2C devices. Remember, we are using the ESP32 GPIO21 for the SDA line and GPIO22 for the SCL line. We now need to add a handler for the I2C master bus. Now we add the code to configure the I2C bus. In this example, we call the I2C master. I will discuss the I2C master and slave buses in a future video, but for now we just go with the I2C master. Now add the I2C master cleanup method. Now we add a handler for the slave devices we're adding to the master bus. Let's add a method to send some data to an I2C device specified by the device handler. This method will return an error if the device does not exist, and we'll handle the error in the calling method. We will now add the method to scan the I2C bus for devices. Let's add the data to send to a device. We add a for loop to scan the device addresses 1 to 127. I2C addresses are usually 7 bits long. Now we add the code to add a slave device to the current address. We check the error on return from adding the device to the master bus. Only continue to the next step if there is no error. The call to I2C master bus add device returns a reference to the device handler, which is later used when sending data to the I2C slave device. Now we try to write some data to the I2C device at the current address. If no error occurs, the existence of the device is printed to the monitor. Now, turning to the app main method, let's add the calls to the I2C scanning methods. Now let's build a project. Press the Build button on the ESP-IDF extension status bar. The build process can take several minutes to complete. There are a few build errors. Let's fix them. Now rebuild the project. I see we still have a few more errors, so let's fix those and then rebuild. Rebuilding the project. Now the project finally builds successfully and all the errors are fixed. After the build completes, press the flash button on the ESP-IDF extension status bar. This will flash your device. After flashing completes, press the monitor button on the ESP-IDF extension status bar. You will see on the monitor the addresses of the devices found on the I2C bus. In my case, I see addresses at Hex 38, which is a AHT temperature and humidity sensor, and Hex 3C, which is an OLED display. Here are some exercises for you to try out. The exercises are designed to help you apply what you've learned and to encourage you to research solutions. I suggest you use this project as a basis and make any changes accordingly. Exercises 2 and 3 will form the subjects of future videos. Well, that just about wraps up this tutorial. I hope that you found this video useful and that your project worked successfully. I also hope that you'll consider pressing the like button and subscribing to the channel. These things are free for you and they really do help the channel develop. I will be posting more videos on ESP development regularly. If you have any specific ESP32 development project ideas you'd like me to cover, then please place them in the comments. And if you'd like access to the source code and circuit designs, then why not become a channel Patreon member? Please see the link in the description below. Thank you for watching and bye for now.